My name is Marcus, and this is, sort of a teaching lesson on the gas laws. A lot of people wonder about them, but they don't really know how this works. And so we're going to cue the titles, no music. I'm just going to go straight into it then. So we're going to start off with Boyle's law, which is pressure 1, volume 1 times pressure 2, volume 2. And pressure and volume, they're indirectly related. So what that means is when the pressure goes up, they're going to collide more. So obviously there's not going to be as much space in the volume, but when the volume goes down, there's not when the volume goes down, there's going to be a lot more collisions. So that means the pressure is going to go up. So that's Boyle's law. And then we're going to have a Lusak's law, which is pressure 1 over temperature 1 equals pressure 2 over temperature 2. So obviously when the temperature's up, they're going to move around faster and collide more, which is pressure. So when the temperature goes down, they're not going to collide. That means the pressure goes down. They don't want to see each other. So that's Lusak's law, and the equation for that, I think I already said it, but pressure 1 over temperature 1 equals pressure 2 over temperature 2. Make sure you know that. That's a key one. The next one we're going to talk about is Charles's law. Now, a lot of people know a lot of Charles's. There's a lot of them in the world. That is volume 1 over temperature 1 equals volume 2 over temperature 2. And volume and temperature directly related, okay? When volume goes up, obviously, there's going to be more space because they're moving around faster. There's high temperature. When there's low temperature, not going to cover much ground. Those particles, they don't want to move. So that means the volume and temperature are both going to go down. Directly related. Next up, we're going to talk about what pressure is using a mathematical formula. What this all means. So standard pressure is 1 atm, which is also, let me get my chemistry sheet here, 101.3 kPa, 760 mmHg, 14.7 psi, and 76 cmHg. So that is standard pressure. A lot of people say, what is pressure? Pressure is the collision between particles and the container. So that means that's how fast they're moving, how much time they collide. Inside here, there's so many particles going faster and slower. That's the collision. That's the pressure inside of here, which makes it what a balloon is and what happens inside. And then we need to talk about, a list of pressures and temperatures used in the gas laws. So we need to know which one we're using. So pressure is kPa, mmHg, atm, and then we have temperature, Celsius, Kelvins, Fahrenheit. So I can't use Fahrenheit, and I can't talk about pressures in Fahrenheit. People got to know so they know the gas laws. A lot of people are just confused. So some key things to remember overall: higher temperature, more energy, move faster; higher pressure, directly related with temperature and pressure. But when you have pressure and volume, those are indirectly related. They're going to make each other go up or down based on which one's increasing. So if your volume goes up, your pressure is going to go down. Sorry, I'm a little bit nervous. I've not done a lot of videos on the gas laws. And then the pressure, when the temperature goes up, so is the volume and the pressure, because those temperatures directly related with those two, because that's what happens in a balloon. So I think let's just go over a quick recap. Boyle's law, pressure 1, volume 1, pressure 2, volume 2. Lusak's law, pressure 1, temperature 1 equals pressure 2, volume 2, or temperature 2, volume 2. Charles' law, volume 1 over temperature 1 equals volume 2 over temperature 2. Important laws for your mathematical equations. All right, mathematical relationships. And let's go over the relationship again with the volume and pressure and temperature. Volume and pressure. Indirectly, volume goes up, temperature goes down. Why? Because they're not moving as fast. They're not going to cover so much space. Pressure and temperature, overall, you already know those are directly related. Because there's more temperature, they're going to be moving faster. They need pressure. Temperature goes down, those pressures aren't moving. It's not as much pressure. And lastly, temperature and volume. When there's a lot of temperature, they're going to cover more ground, more volume. Less temperature, they aren't moving fast, there's no volume. So that's mostly what you need to know about gas laws. Kelvins equals, when you need to find Kelvins, you add 273 to the Celsius, and when you have Celsius, when you need Celsius, you take the Kelvin and subtract 273. Hope you know a lot about ideal gas law. That's PV equals nRT. That's the main formula you're going to need to find that gas. Dalton's law, P total equals P1, P2, P3. Keep going to find the total gas, but I guess that's all you need now. That's the main stuff about the gas laws, about the mathematical equations, how the things are directly related, and see this balloon, now you know what it does. Alright? See you later. Thanks. Sorry.